Have you ever wondered how batteries power our gadget or how metals get purified? It's all electrochemistry. Electrochemistry focuses on the movement of electrons in the chemical reaction. Electrochemistry is a science behind how electricity and chemistry works together. It is a fascinating blend of theory and real life application that powers our modern life. So let's try uncovering the magic of electrochemistry together. Before we start uncovering the magic of electrochemistry, let's first understand what all topics are we going to cover in this particular part of electrochemistry. So first, very important is conductor and insulator. We are going to define what are conductors, insulators, how they are different from each other, then types of conductivity, electrolysis, then we'll talk about basic electrolytic cells. We'll try to label all the parts of electrolytic cells, then we'll understand how do we predict the products at different electrodes. Okay, then we'll talk about electrolysis and how the charge and electrons flow through it. Then we will discuss about Ionic half equations, and by the end of this video, for our practice, we will do some related questions for our practice. So let's quickly dive into it. The first topic is conductors and insulators. So what are conductors and insulators? This is very important for us to understand because this is key difference point between metals and non-metals. How metals are different from non-metals. So the property of metals is to conduct electricity because they have delocalized free electrons. So because of flow of electron, it can conduct electricity. But non-metals cannot conduct electricity. There is one exception. Rest all cannot conduct electricity. So let's read quickly. So ability to conduct electricity is the major simple difference between metal and non-metal. All the metals can conduct electricity, but non-metals cannot conduct electricity, but there was one exception, as I told you. So that exception is graphite. Graphite is the allotrope of carbon. You can mark this and put a star over it that this is an exception. It is the only non-metal that can conduct electricity. Why? Because it has a structure in that way. We have discussed the structure of graphite, diamonds and silicon 4 oxide in the previous chapters, so you can go and check that out. So in that we have understood that graphite structure is such that it has layers, okay, and then there are delocalized electrons due to which they can conduct electricity. Okay, now let's quickly define what are conductors and what are insulators. So conductor is any substance that can conduct electricity or that has a free electron due to which the electricity can be conducted. Okay, and very important thing is while they are conducting electricity, it do not get changed. Okay, chemically they remain the same. For example, we have copper wire. So while copper wire is conducting the electricity, it doesn't change its composition. Okay, it remains copper wire while the current is flowing through it. Okay, so electrical conductor, a substance that conducts electricity but is not chemically changed. Important. Okay, it does not change. The copper wire remains copper while it is conducting electricity or even if it is not conducting electricity. Okay, next is your insulator. Now, what are insulators? Any substance that cannot conduct electricity, like for example non-metal, other than graphite, all the non-metals, they cannot conduct electricity, hence they are insulators. So solid covalent non-metals do not conduct electricity, whether they are giant, simple or any type of structures. Okay, why they cannot conduct electricity and why they are insulators? Because this is important, there are no electrons that are not involved in the bonding. There are no free electrons because there are absence of free electrons, hence they cannot conduct electricity. So for electricity to be conducted, either there should be free electrons or moving ions, free moving ions. Okay, one of the two should be present to conduct electricity. Okay, now you can take a minute here, pause the video here and you can note down the important point. Okay, now let's move on to the next topic. So types of conductivity. As I told you in the previous slide also that electricity can be conducted if they have either free electrons or free moving ions, right? So we can understand what type of conductivity there are. So there are two types of conductivity. One is conductivity in metals, in which the conductivity is due to free electrons. Okay, so the reason is free electrons. And the another type of conductivity is electrolytic conductivity, in which the reason is flow of electron. Okay, this is very important. You can note this thing down. Then another thing, what is conductivity in metals? So it is a property of elements and alloys, as we have mentioned earlier also, that conductivity in metals is actually a property, very important property. It is a differing property between metals and non-metals, right? Next, it takes place in solids and liquid. It can take place in solid, like for example, copper wire is solid while it is conducting electricity, and it can take place in liquid as well. For example, mercury is a liquid metal, right? It is liquid in the room state, so it can conduct electricity. Next is no chemical change take place. Again, we have done this already, that there is no chemical change taking place while the electricity is being conducted in metals, right? Now let's move on to the electrolytic conductivity, in which I told you the main reason for electrolytes to conduct electricity is moving of ions or free movement of ions. A property of ionic compound, okay? This is a property of ionic compound, but metallic conductivity was property of elements or alloys, okay? Then there is chemical change taking place during conductivity. Like in this conductivity in metals, there was no chemical change taking place, but in the case of electrolytic conductivity, there is chemical change taking place while the electricity is being conducted, okay? So this is a important point over here. Next, it takes place in liquid solutions only, but in this case, it was taking place in solid and liquid both, right? I gave you an example also for solid. For example, copper is a metal in which electricity can be passed, and liquid you can say Hg, which is mercury, okay? But in case of ionic compounds can only conduct electricity when they are either molten or they are present in aqueous solution, okay? Either they have to be molten or they have to be diluted to conduct electricity. Why? Because in the previous chapters also we have discussed that ionic compound have this type of lattice, in which positive and ionic charge, positive and negative charge are placed together in a regular form, and there is very less intermolecular space. So in this case, the ions cannot move easily, and if they cannot move easily, they cannot conduct electricity, okay? So for this ionic compound to conduct electricity, we have to provide either heat to melt it, or we have to dilute this so that the ions break down, okay? And in this form only they can conduct electricity, right? In which the ions are apart from each other, the intermolecular spaces is greater, so they can move, okay? So what we need these ions to move, right? So they take place in solid and liquid solutions, not liquid and solutions, not in solid. This is important. Why? This question is repetitively asked in your previous questions, if you check that out. So make sure that you note this point, okay? This is very important, that why ionic compounds do not conduct electricity in solid state. So solid ionic compounds will not conduct electricity because the ions are fixed in position, as you can see in this, okay? They will only vibrate at their fixed position, but they are not free to move, right? So they are fixed in position in a solid, they cannot move. The electrolyte must be melted or dissolved in water for it to conduct electricity, okay? Only then it can have free moving ions, okay? So two things we can do with such ionic compound: either we can melt it by providing heat, okay, or we can dissolve it in solvent, okay? Either of the two we can do for this ionic compound, which has such regular fixed positioned ions in it with less intermolecular space, for this to move apart, and then they can conduct electricity, okay? Now take a minute and please write down the difference between conductivity in metals and conductivity in electrolyte, okay? Okay, now let's move. So what is electrolysis? This is very important. So as the name suggests, let's break it down and let's try to understand what is electrolysis, okay? So electro word comes from electricity, so it has something to do with electricity for sure. And lysis means to break down, okay? To break down. So something is breaking down when electricity is passed through it, right? Now let's read the definition. Electrolysis is the decomposition of an ionic compound. What is ionic compound? The diagram, if you remember, this one, this is an ionic compound in which ions are present in regular form. Okay, then the decomposition of an ionic compound when molten or in aqueous solution by the passage of an electric current. Okay, so what is electrolysis? Electrolysis is a process, or it is a method in which this ionic compound, which was initially present like this, it is either melted or dissolved so that it is present like this, so that it has free ions and it can conduct electricity. So this process of conversion of ionic compound from its solid state to its free moving ion state, that process is known as electrolysis. Okay. Now, what are electrolytes? So electrolytes are those liquids that can conduct electricity. Okay, so liquids that conduct electricity by movement of ions, those are known as electrolysis. Like for example, you have NaCl. Okay, NaCl is your common salt, sodium chloride. When it is dissolved in water, it breaks down, or it decomposes into its ions, which are Na plus and Cl minus. Now it has free moving ions, cations and anions, hence it can conduct electricity. So I can say that NaCl in aqueous state, it can conduct electricity, hence it is an electrolyte. Okay, next is non-electrolyte. So just opposite of it, liquids that do not conduct in this way are known as non-electrolyte. This is a simple table which we understand that how electrolytes are different from non-electrolytes and what are the examples. So sulfuric acid is H2SO4. It can also break down into its ion in liquid state. Okay, hence it can conduct electricity. And non-electrolyte, for example, ethanol, petrol or distilled water, they cannot conduct electricity. Okay, because they do not break down or decompose into its ions. I hope this is clear. What do you mean by decompose or decomposition? It is a type of chemical reaction in which a compound breaks down into simpler substance. For example, I gave you NaCl, another example NaOH. This is a base, sodium hydroxide. So if I dissolve it in water, or it is present in aqueous state only, it breaks down into its ions, or I can say it decomposes to give ions. Okay, Na plus and OH minus. Na plus and OH minus, right? So this is an example of decomposition reaction. And what is decomposition, right? Now let's move on to the next part. So electrolysis general principle. So let's understand what is general principle of electrolysis. As the word suggests, everything is in the word only. When an electric current is passed through a molten ionic compound, the compound decomposes or breaks down. For example, this. Okay, when I pass electricity through it, it will break down the bonds, or maybe I can say that it will move apart from each other. Hence, I will get free moving ions like this. This is electrolysis, right? The process also occurs for aqueous solution of ionic compound, as we already mentioned this. Covalent compounds cannot conduct electricity. Why? Because they do not have free ions, or they do not have free electrons, right? Ionic compounds in solid state cannot conduct electricity since they have no free ions. Already we have discussed this over here, right? I hope you have noted this thing down, because this is important. Okay, next let's move on to what really electrolysis is and how, in what apparatus does it take place. So electrolytic cell is the apparatus in which the process of electrolysis takes place. Okay, this is a basic simple electrolytic cell. We'll understand this. Let's first read the important definitions or points of few words. So first is electrode. Electrode is a rod of metal or graphite through which an electric current flows into or out of the electrolyte. So this is, I told you, this is a simple electrolytic cell. Here, where are electrodes? So this is an electrode, okay, and this is an electrode. They are usually made up of graphite, okay, or platinum. I am writing PT. Why they are usually made up of these? Because these two are inert in nature. Inert means they are unreactive. So they will not react with the electrolyte, okay, or the solution which is present inside of this beaker. They will not react with this. Hence electricity, like electrolysis process is not disturbed. Hence we usually use graphite or platinum made electrodes. Okay, so graphite or platinum electrodes. Okay, next the solution which is present over here, which will break down into its ion during this process of electrolysis, this solution is known as electrolyte. Okay, this is known as electrolyte. Next, now because we can see that there are two type of electrode, positive electrode and negative electrode. So there are two different names to label. Okay, so positive electrode is known as anode, A-N-O-D-E. Okay, anode. And the negative electrode, which is also made up of graphite or platinum, this is known as cathode, C-A-T-H-O-D-E, cathode. Okay, and then there is a battery. So this is very important, that how is battery placed. So negative terminal of the battery should be towards the negative electrode, because the negative terminal will pump electrons and it will provide this negative terminal with the electrons. Okay, so this negative terminal or the cathode is rich of electrons. Okay, this is rich of electrons. Let me write down here, rich of electrons. Why? Because it is placed near the negative terminal of the battery. And the anode, which is positively charged, it is deficient of electrons. So basically the electrons move from here, then to cathode, then in the electrolyte, and then to anode and back to the battery. Okay, this is the movement of the electrons. We will discuss this in further slides. Okay, so this is the basic thing. Now let's quickly read. So electrode is a rod of metal or graphite through which an electric current flows into or out of the electrolyte. Then electrolyte is the ionic compound. So this is an electrolyte. There we will find an ionic compound which is to be broken down during the process of electrolysis. Okay, next is anode. So anode is a positive electrode. I already told you, we have already mentioned that it is a positive electrode of an electrolysis cell. Next is anion. Okay, so there are two type of ions. We know that there are two ions. One is cation, another one is anion. Anion and cation. This we already know from our previous chapters. Cation is positively charged ion, like for example Cu plus 2 or Ag plus, okay, or I can say chromium. Okay, then anion are negatively charged ion, like for example Cl minus fluoride, F minus fluoride, or Br minus bromide. Okay, these are negatively charged ion and they are known as anion. Okay, now we know opposite attracts. So if there is a positively charged electrode, the negative charged ions will be attracted to, and the negative charged ions are known as what? They are known as anion, right? And the positively charged ions are known as what? They are known as cation, right? So can I say that cations are attracted by cathode and anions are attracted by anode? Okay. Then next is cathode is a negatively charged or negative electrode. We have already written there. Okay, of an electrolysis. Cation is a positively charged which is attracted to the cathode. Okay, remember that opposite electrodes will attract opposite charge. Like if there is a positive electrode, it will attract negative charge. Okay, if there is negative electrode, it will attract positively charged ions, right? So can I say that because metals are usually positively charged, not usually, they are positively charged species, right? So metals will always be found near where? Cathode, because they are positively charged, so they will always be found at a cathode. And non-metals are always found at anode, right? Because they are negatively charged. Okay, so I can say metals, and there is an exception that hydrogen is also present. Okay, so metal and hydrogen are always found at cathode, and non-metals are negatively charged ions, so they will always be formed near anode. There is an exception, of course, this hydrogen. Okay, now take a minute here and please note down everything, then we'll move on. Okay, now let's move on. So movement of ions, as we have already discussed, that positively charged your electrode and negatively charged electrode, they will attract the oppositely charged ions. Okay, so this is cathode, right? This electrode is cathode. and it will attract what? Cations. There is a mnemonic also to remember this. Mnemonic is panic, P-A-N-I-C, okay, which says positive is anode and negative is cathode. Okay, this will help you to remember, right? And then what is attracted by anode? So anode starts with A, so it will be attracted by anions. Okay, this way you can remember. So anode attracts anions and cathode attracts cations, CC. Okay, C and C, A and A. Okay, this way you can remember. Now quickly write this thing down. If you will not write it, it will be difficult for you to understand and it can create confusion. Okay, so please take a moment here and you can write this thing down. I hope you have noted this thing down. Now let's move on to practice some questions. Okay, let's see how much we have already learned. So the question says, which of the following will conduct electricity? Okay, so the options are given to us. We have to tell which will conduct electricity. So we know what conducts electricity. Either it should be a metal or ionic compound, aqueous ionic compound, okay, not solid. So let's check. A strip of copper metal, yes, it is a metal, so it is definitely going to conduct electricity. First is correct. Then a solution of sugar in water, no. If a sugar is dissolved in water, it will dissolve, but then it will not break down into its ions, okay. So no, it is not an ionic compound, so this cannot be your answer. Then aqueous sodium chloride solution, yes, sodium chloride, or I can say NaCl is a compound between a metal and a non-metal, hence we can say it is an ionic compound. Okay, this is ionic compound and it is in aqueous state, right? So yes, this is definitely going to conduct electricity. Next is mercury. Mercury, or I can say Hg, it's the symbol. Okay, so mercury is a liquid metal. Okay, it is liquid in at room temperature. So yes, this is definitely going to conduct electricity. Next is your dilute hydrochloric acid. So hydrochloric acid is what? Hydrochloric acid is HCl. Okay, it is dilute, it is in aqueous state, right? Hence it can break down into its ions, which are H plus and Cl minus, cation and anion. If it can break down into its ions, hence I can say that it has free moving ions, therefore it can conduct electricity. Next is melted sugar. Again, I told you sugar is not an ionic compound, hence it will not conduct electricity. So the correct answer for the first part is 1, 3, 4, 5. Okay, this is the answer. Next is your B part, which says which of 1 and 6 are electrolytes. Now what are electrolytes? We have seen a table, right? Earlier we have seen a table in which electrolytes and non-electrolytes example were given to us. Okay, we have already discussed that. Now let's try to answer this question. Okay, so which of them are electrolytes? So first, electrolyte means that substance which can conduct electricity when it is dissolved in water, okay, or when electricity is passed through it, like any aqueous ionic compound. Okay, so third is your answer. Why? Because third is aqueous sodium chloride. Aqueous sodium chloride is a aqueous NaCl I am writing, because it is aqueous ionic compound, hence it can conduct electricity, hence it is a electrolyte. Next is your fifth, which is dilute hydrochloric acid. So HCl or hydrochloric acid is also an example of electrolyte. Why? Because it can break down into its ions H plus and Cl minus, and hence it can conduct electricity, right? So these are the correct answers of the question. You can note this. Next, let's move on to electrolysis, charge transfer. So I think in second or third slide I explained how the electrons or ions move in the circuit or in this electrolytic setup, but let's explain. Let me explain you again this part, okay, so that you can also note down the important points if you wish to. So what happens? You can see that there is a negative terminal of battery, right? So negative terminal of battery will pump one electrode with charge or with electron, I can say. Okay, so here electrons will be pumped from the battery. So I can say cathode will then have a negative charge over it, or a negative electrode will be formed. Okay, initially let's say that there was the battery was off. Okay, there was no flow of charge or current or anything. At that time, both the electrodes are normal electrodes. Okay, they are both neutral, they do not have charge over it. But once I switch on the battery, what happens? The negative terminal of the battery pump the electrons in this particular electrode, and hence it will have a negative nature or negative charge. Why? Because it is full of electron, it is rich of electrons. So it is known as cathode. We have already understood this, right? So let me write here, this is rich of electrons. Why? Because from the battery the electrons are pumped on the cathode. Now what we studied earlier is that there are two types of ions, cations and anions. Cations are positively charged ions which are deficient of electrons. Okay, so they need electron to fulfill their requirement. So what happens? The positively charged, can you see, positively charged cations will come to the cathode to gain electron. Okay, can I write here? Positively charged ion, which is known as cation, will come to this cathode to gain electrons. Okay, to gain electron, right? This is the participation of positive charge. Now let's talk about anode. So anode is a positively charged electrode, which means that it is electron deficient electrode. Okay, electron deficient electrode, it doesn't have electrons. Okay, so what species will come? Which ionic species will come? The ionic species which is full of electrons, which is rich of electrons, that will come to anode and it will donate its electron to anode. Okay, so negatively charged species, which are known as what? Which are known as anions. Okay, anions, or let me write negatively charged ions. Okay, they will come to anode and they will donate their electrons. Donate electrons at anode, right? Got it? Now let's quickly read. Okay, now two things are happening before we begin to read. Let's understand two things. Two things are happening. Electrons are flowing in the outer circuit or the external circuit, but ions are moving in the electrolytic, like electrolysis or this electrolytic cell. Okay, so two type of movements are happening. What? Electrons are moving in this external circuit and the ions are moving inside of this beaker or in the electrolytes. Okay, so these 2 points I want to read first. Electrons are the charge carriers in the external circuit. Okay, and ions are the charge carriers in the electrolyte. Okay, this is the electrolyte. Okay, now let's quickly read. During electrolysis, current needs to flow around the circuit. Yes, we know. The power supply provides the cathode. This is important. This is what I was explaining. So if you wish to write this thing, you can write. So cathode provides a supply of electrons, causing it to become negatively charged. Power supply provides the cathode with supply of electron. The negative charge of this power supply, that will provide electrons to this cathode, that will make it electron rich and hence a negative charge over it. Okay, next, positive ions or cations in the electrolyte move towards the cathode where they gain electron. Okay, already mentioned, they will gain electron because it is negatively charged, it is rich of electrons. So species which are deficient of electrons will come to it to gain the electrons, right? Next, negative ions or anions in the electrolyte move towards the anode where they lose electron. Okay, donate electron or lose electron. Lose electron. Okay, then the electrons move from anode back towards the cathode. This is what I told you. Electrons move from this and then to this. Okay, next, so in a complete circuit, electrons are the charge carrier in the external circuit and ions are the charge carriers in the electrolyte. Okay, electrons move here and ions move here, right? What we are doing, we are providing electricity, and due to that which we are providing, which is electricity, due to that what happens, the ions break down and they attract the electrodes, oppositely charged electrodes. Okay, so take a minute and note down this. Okay, now let's move on. So next part is, again, this is just an introduction. We will do this in detail in your second part. So let's just read it. Okay, ionic half equations. Now what happens? From the previous slide, we understood that positively charged electrode, which is anode, ANODE, okay, this anions will be coming to it, okay, or negative ions will be coming to it, okay. Here, positively charged electrode, which is anode, electrons will be coming to it. Now this process is known as oxidation. Okay, here what is happening with this ion, or what is happening to this anion? They are losing electron. When they'll come here, they will lose their electron because this is positively charged species. For example, a chloride ion comes, Cl minus. It has extra electron. When it will come here, it will lose one electron. So it will give one electron to this positive anode. Okay, and what it will become? It will become Cl. Got it? This will happen, and this process of losing electron is known as oxidation. Okay, so what is oxidation? Oxidation is loss of electrons, right? Now, here we have also mentioned this. So there is another mnemonic to remember this thing, and the mnemonic is OIL RIG. What does it mean? Oil rig. It means oxidation in oxidation is loss. Okay, oxidation is loss, so that you understand oxidation and reduction well before the coming chapters. Okay, so oxidation is loss and reduction is gain. Okay, what is reduction? Reduction is gain of electrons, right? This is mnemonic. You can write this and put a star over it, that it is important. Okay, this will help you to memorize it nicely. Okay, now what happens? The chloride ion example is clear, I guess. Now what happens with cathode? Because cathode is negatively charged electrode, it already have electrons over it. Okay, it is full of electron, it is electron rich. So what type of species will it attract? It will attract a species which is electron deficient. Okay, so positively charged ions will come over here, like for example Na plus. Okay, it doesn't have electron, it needs electron, so it will go to negatively charged cathode, and then it will gain electron from here and it will become Na. I hope this is clear. Take a minute and please write this thing down. Before leaving the slide for you to write it down, let's also define one more thing. What is half equation? So half equation is this only. When we write separate equations explaining what is happening at particular electrode, that is known as half equation. For example, this is a half equation. What is happening at anode? Cl minus visit anode electrode. Okay, it leaves it electrons. See, it is leaving it electrons and it becomes Cl. Okay, it loses that charge over it. So this is what? This is a half equation, or I can say this is anode half equation. And what about the another equation? The cathode, wherein reduction is taking place. So what happens? Na plus or positively charged ion will come, which needs electron. So it will come to cathode. It will take electron from cathode and it will become a neutral species, which is Na. Okay, which is Na. So this is a I can say this is a reduction half equation, or maybe cathode half equation. Okay, next thing is when ions touch the electrode, electrons are either lost or gained. Yes, we know that. Over here, for example, what is happening? Loss of electrons is happening at anode. Okay, and over here, what is happening? Gain of electrons are happening. Gain of electrons are happening at cathode. Okay, creating a neutral substances. Yes, we know Cl minus visited and came out as Cl. And over here, Na plus visited and came out as Na. So they become neutral, okay, after losing or gaining electrons. These neutral substances are then released as product at the electrode. Okay, that we will understand in detail in your second part. Before that, let's just write down the basic things. Okay, very important. This is very important for you to understand the fundamentals of electrochemistry. Only then your basics and concepts will be clear. So take a minute and write this thing down. Okay, now let's try a few questions for us to practice. So first is, why is sodium potassium bromide a non-conductor of electricity? Very easy. How can a solid ionic compound conduct electricity? It has to be either molten or diluted for it to conduct electricity. Okay, so its answer is nothing but what we have already discussed. Let me show you. Okay, here. Okay, so this part I told you to write this thing down because it is very important and a lot of questions were asked in the previous questions as well. So solid ionic compound will not conduct electricity because the ions are fixed in their position. Can you see? Fixed position of ions in a solid. They cannot move. The electrolyte must be melted or dissolved. This is what I was explaining, okay? For it to conduct electricity. So yes, same answer. What? Solid ionic compound, which is over here, they are saying KBr, potassium bromide, cannot conduct electricity as the ions are fixed in their position. Fixed in their position. Okay. So either melting it or dissolving it can make it conduct electricity, right? Very easy. Next, suggest two things that could be done to potassium bromide that would make it conduct electricity. We have already answered this part in the first part itself. Either melt it by providing temperature, high temperature or heat, or what we can do is dissolve it. Okay, dissolve it. Right, these are the two things which we can do for it to start conducting electricity. Next is, explain the major difference between electrical conductivity in metals and solution in terms of the particles that are carrying the current. Okay, so these questions are from your book itself, so you understand the importance of them. So what is the difference between electrical conductivity and metal conductivity? Already studied. We have already studied here, and I asked you to write this because it is important. So what is the difference in conductivity in metals? The reason for the conductivity is flow of electrons, okay, and the reason in electrolytic conductivity is free moving ions or flow of ions, right? One difference point is this. Another one is that no chemical change take place in conductivity in metal. Copper remains copper whether it is conducting or not, okay, but in case of electrolytic conductivity, decomposition takes place. So there is a chemical change taking place. Hence, let's quickly write down the difference. Okay, so electrical conductivity, and this side I am writing electrolytic conductivity. Okay, so the first point can be the reason. Okay, reason for conductivity is free electrons. Free electrons. Okay, and here we can write reason for conductivity. Okay, reason for conductivity is flow of ions, right? First difference point is this. Second difference point is no chemical change. No chemical change takes place, right, during conductivity. And in case of electrolytic condition, what happens? Chemical change. Chemical change, in bracket I can write decomposition, because the ionic compound decomposes, right? Decomposition takes place. Okay, this is the next key difference point over here. Next, your fourth question is, identify the products formed at the anode and the cathode during the electrolysis of molten potassium chloride. So molten, yes, it can conduct electricity. Potassium chloride is nothing but KCl, right? What is anode and cathode again? So I gave you that mnemonic. What was the mnemonic? Panic, PANIC, which says positive is anode and negative is cathode. You remember? Let me write down. Positive is anode and negative is cathode, right? Now we know the charges of the electrodes. So we can say the positive ion. What is the positive ion in KCl? K plus plus Cl minus. So whatever substance or whatever element we are writing first is actually a metal or a positively charged species. Okay, so this will be positively charged species, this is negative. Okay, whatever we are writing behind or at the end, that is your non-metallic species or a negative species. Okay, so this is how it will break down. So we know positive is anode, so it will be attracted by negative, which is your Cl minus, or which is known as anion. Let me write down, this is cation, this is anion. Okay, we know that cation will go to cathode and anion will go to anode, right? So how will we write the answer? Let me write the answer here. At anode, anion will come, and what is anion? Cl minus, Cl minus, and at cathode, which is your negative, K plus will come. Okay, this will be your answer. Take a minute and note down the correct answers. Okay, so here we come to the end of the first part of electrochemistry. I hope you enjoyed this lecture, and it made electrochemistry easy for you to understand. We also discussed few mnemonics for you that will help you to, memorize the few things easily. And let's meet in the second part of this video. Before that, don't forget to like this video and share your appreciation. Until then, keep learning and enjoy. Thanks for watching, and I'll see you in the next video. Till then, don't forget to like, share and subscribe to our channel.